Hi, everybody. In this video, we are going to talk about proportions and in particular, how they apply to some aspects of geometry. So the first vocabulary word that's really important is this word proportional. When we say that something is proportional, we are describing when quantities have the same relative or similar size. So for example, if I made some cookies, and let's say the recipe called for a batch of 12 cookies. If you made the recipe and it made 12 cookies, if I doubled the batch, if I wanted to make 24 cookies, then that means I would have to take all of my ingredients and I would have to double the amount in order to make double the amount of cookies. So you could say that the recipe for 12 cookies and the recipe for 24 cookies, they should be proportional to each other. They're not exactly the same recipe, but they have to be a relative or similar amount of ingredients based on how much it is for a certain amount. I hope that made sense. If we're looking at, let's say, we were looking at the White House. I don't know if you guys have ever been to a museum where there's been some sort of White House replica, but sometimes what people do is they make, a replica of the White House or of the Eiffel Tower or of some other building. And when we create those images or when someone engineers that design, they have to look at all of the dimensions and engineering and architecture of those buildings, and they have to create models and materials that are of a proportional size to the original building. You can't create the White House that looks exactly like the White House, just in a little miniature form, if you don't know the exact measurements of the actual White House and kind of convert them to a proportional size. So that's going to make a little bit more sense when we see some of the images here in this particular video. So this is the definition of proportional. Make sure you write that down. The next thing is we're going to start talking about this word similar. So when we say two shapes are similar to each other, we are describing two shapes that are proportional to each other. So all similar figures have to have these three characteristics that we're about to go over. So if you're looking at two images and you're comparing them, in order to check to see if they are proportional to each other or if they are what we call similar to each other, they have to have these three characteristics. So the first characteristic is similar figures have to be the same shape. If you're comparing a triangle and a rectangle, they cannot be similar figures. They're not even the same shape. So they have to be the same shape, but they have to be different sizes. If you're comparing the same shape and they're the same size, then you would say those are equivalent figures to each other. But they're the same shape and different size. That's one aspect of being a similar figure. So let me draw you some examples. So let's say we have a small triangle, but then a larger triangle. Let me draw a different kind of triangle. A right triangle, a baby right triangle, and then a bigger right triangle. So you notice they have to be the same exact shape. So these, they kind of look like isosceles triangles. They both have to be isosceles triangles. An isosceles triangle is not the same thing as a right triangle. So those are technically different shapes, an isosceles triangle and a right triangle. So they have to be the same exact shape. So isosceles triangles with each other, right triangles with each other, or you could have, let's say, a rectangle and then a larger rectangle. Same shape, but just different sizes. That's the first characteristic. Now, the next two characteristics have to do with the sides and angles of the shapes. So for this part, I would encourage you, if you have at least, aside from like your pen or pencil, get 3 other colors, because we're going to use a triangle, and a triangle has 3 sides and 3 different colors is going to be kind of helpful to visualize the next part of what we're going to do. So the second characteristic, and this is kind of what you're going to use the most, as you'll see in the second video, when it comes to looking at two figures and determining if they are similar to each other. What has to happen is the corresponding sides in the two shapes have to grow or shrink, so increase or decrease, by the same multiplier that's called the scale factor, okay? So when we look at our shapes, I'm gonna draw them in a moment. When we look at the length measurement of the sides, they have to grow or shrink by the same amount. We have to, in order to get from like the length of this side to the length of this side, the length of this side to the length of this side, the length of the third side to the length of the third side, we have to be multiplying all of those sides by the same number, and it has to show up equivalent over here. So let me show you kind of what I mean by that. Let's draw ourselves two triangles. Make sure I have some space. Okay, let's draw ourselves two triangles. I'm going to draw a smaller triangle first. I'm also going to draw right triangles. So let's say I have this right triangle, and then I'm going to draw a slightly larger right triangle. Okay, and I am going to give all of my sides a measurement. So I'm going to say 3, 2, and 4. Okay, those are technically, they don't really work as right sides, or I'm sorry, they don't work as sides for a right triangle, but just go with it. And then on this side, I am going to label them 6, 4, and 8. Okay, so if these two triangles are similar to each other, okay, if I look at the corresponding sides in each triangle, so I'm going to take my first color and I'm going to label the first pair of corresponding sides. So this side right here with 3, this side corresponds to this side of the larger triangle. They are the same side of the two different triangles. They're both, you could think about it, they're both the left side of the triangle. I'm going to take another color. If I look at the bottom part of the triangle, this bottom side corresponds to this bottom side of the bigger triangle. And then take your last color and label the third sides. This side of the smaller triangle corresponds to this side of the larger triangle. Okay, so if I look at the corresponding sides, I have to look at the numbers and I have to determine, am I multiplying by the same thing in each situation? So for example, to get from 3 to 6, I'll write it over here. To get from 3 to 6, I am multiplying by 2. 3 times 2 is 6. To get from 2 to 4, to get from 2 to 4, I am also multiplying by 2. To get from 4 to 8, from 4 to 8, I am also multiplying by 2. So this value right here that I am multiplying by, okay, or another way you can kind of draw it if you want, you could, like some people, what they do is they circle both numbers and they draw an arrow, okay. This value right here, okay, this is that scale factor. This triangle, the larger triangle, is twice the size of the smaller triangle. If it was the opposite, if I was comparing the bigger triangle first, then the smaller triangle, the scale factor would be half. This triangle is half the size of this triangle. But scale factor is always what we are multiplying by. And a key thing here is when we look at our shapes, or when we look at our similarity statements, which you'll see what that looks like in my last characteristic example, we read from left to right. Okay, in math, we always read left to right. Okay, so from left to right, we're going from a smaller to a bigger shape. Sometimes it's important to note that because we forget. Okay, we're going from a smaller to bigger shape. So when we're multiplying, our scale factor is going to be a number greater than 1. However, if we looked at it the other way, 6 times 1/2 is what gets us 3. 4 times 1/2 is what gets us 2. 8 times 1/2 is what gets us 4. So if it was the other way around, the scale factor would be 1/2. Okay, it's always what you're multiplying by. Multiplier is kind of a key word. All right, in the next video, you'll see an example of a scale factor that is a fraction. The last characteristic for two shapes to be similar to each other is their corresponding angles have to be congruent. All right, so I'm going to draw another set of triangles. I'll probably just stick with the right triangle situation. I'll draw the bigger triangle first. So I'll draw this triangle, and then I'll draw a smaller right triangle. You're still going to need your 3 colors, okay? And you know what? I'm going to actually label these triangles. I'm going to label these triangles A, B, C on all the corners. And I'm going to label this one D, E, F, okay? So if all of the corresponding angles are congruent, that means equal to one another, then that is the last characteristic to determine if a figure is similar. So if I look at corresponding angles in each of these shapes, angle A, I'm just going to kind of shade in this corner. Angle A is the same as angle D in the smaller shape. These are corresponding angles. In the smaller shape, this angle is the same as this angle here. I'm going to use my other color. Angle B, the right angle, is the same as this particular right angle. These two sides, or I'm sorry, these two angles B and E correspond to each other. And then angle C and angle F correspond to each other. Okay, so if these shapes, or if you're looking at 2 shapes and their corresponding angles are equal to each other, like angle D and angle A are the same measurement, angle B and angle E are the same measurement, angle C and angle F are the same measurement, then that's kind of the last like checkbox to determine if 2 figures are similar. So we would say that triangle ABC, so I put a triangle ABC, is similar to triangle DEF. And the symbol we use for similar is it's a squiggle. Those of you that speak Spanish, it's the ñ symbol. So if you see this symbol, that means similar. So if triangle ABC is similar to DEF, that is how we would write that statement. Again, I'm reading it from left to right. This triangle is similar to this triangle. So in the next video, you will kind of be given 2 shapes, and you are going to have to use these characteristics to determine if they are similar to each other. And you're also going to kind of find out, like, let's say I didn't give you that this side was 4. You can use the scale factor to figure out what is the length of a side of a triangle if you're given a similar triangle to look at. So when we are looking at proportional shapes or similar shapes, they have to be the same size, or I'm sorry, same shape but different size. Their corresponding angles have to grow or shrink by the same scale factor, and their corresponding angles have to be congruent. So if you need to rewind and check out any part of this video, please do. Ask me any questions if you need, and please move on to the next video so you can see some examples of solving proportions within similar figures.